Welcome to the fifth in our series of Aurea evaluation software videos. In this lesson, we'll learn how to parameterize the position tracking feature of Microchip's MGC3130. This includes introduction, electrode dimensions, electrode weighting, E-field linearization, sensing area, Z levels, filter adjustment. The electrode system we use today is the standard 95 by 60 mm electrode, which comes with Microchip's MGC3130 Hillstar development kit. During the position tracking step, a test object simulating the human hand is needed. Therefore, we will use the handbrick set which is provided within the MGC3130 Hillstar development kit. The handbrick set comes as a self-assembly set and consists of one copper-coated handbrick with a thin wire soldered to it, 4 foam blocks of different heights. More information on the handbrick set and how to assemble it can be found in the MGC3130 Hillstar Kit User's Guide. During the parameterization process, we will perform measurements by stacking the handbrick on top of the foam blocks and placing them on different positions on the electrode. At the same time, we hold the wire attached to the handbrick in our hand. The handbrick is coated with copper and therefore conductive. It simulates the human hand. The foam blocks have a permittivity of almost 1, which is equal to the permittivity of air. This simple setup allows us to simulate the human hand on various positions and heights. During measurements, it is important not to disturb the electric field by user interactions, like operating a PC mouse next to the electrodes. It is also important to keep our system mechanically stable and avoid vibrations. Let us start. In Aurea Calibri parameterization, the position tracking step is divided into 7 sub-steps. The first sub-step is Electrode Dimensions, where we can input the electrode X distance and Y distance. X distance is defined as the distance between the west and the east electrode. Y distance is defined as the distance between the south and the north electrode. In our case, 95 mm is the exact value for X distance which we set up with the slider. For Y distance, it is 60 mm. We press Next to navigate to electrode weighting. In this sub-step, we use the handbrick to determine the electrode weighting. On 5 predefined positions, we have to perform measurements. One measurement with handbrick and a second reference measurement without the handbrick. First, we need to place the handbrick on top of the 30 mm foam block and position it on the west electrode. We hold the wire of the handbrick in our hand and press Start Measurement. Aurea is collecting sensor data. We now have 10 seconds to prepare a reference measurement without the handbrick. We remove the brick and press Start Measurement. We can now see the results of both the brick and the reference measurements in the table below. We repeat this procedure for the remaining 4 positions, north, east, south and centre. If we get some values marked in red, meaning that there was noise, for example, caused by mechanical instability such as vibrations, then we need to recheck our setup and redo the measurement. Once done, we have to press the Confirm Values button to continue to the next position tracking step. During the next sub-step, which is called E-field linearization, we place the handbrick in the centre of the sensing area and perform brick measurement at 4 different heights. As in the previous step, for each brick measurement, we also perform a reference measurement without a brick. We place the handbrick on top of the 10 mm foam block and position it in the centre of the sensitive area. We hold the wire of the handbrick in our hand and press Start Measurement. Aurea is collecting sensor data. Again, we have 10 seconds to start a reference measurement without the handbrick. We can now see the results of both the brick and the reference measurements in the table below. We repeat this procedure for heights of 30, 50 and 80 millimeters. To realise 80 millimeter height, we stack the 50 and 30 millimeter foam blocks on top of each other. Let us continue by pressing Confirm Values button. This sub-step is called Sensing Area. Here, we adapt the XY position calculated by the Calibri suite to the real electrode dimensions of the system. For the Sensing Area parameterization, as well as the following two sub-steps, the user's hand posture is important. While touching the cover, you move your hand along the inner edges of the electrodes several times. We hereby use the hand posture which is typical for our application. As you can see, the XY position is drawn in the window below. The red square determines the maximum positions we can reach. In order to guarantee that the user can access all positions and to provide best XY linearity, we scale the area within the red square. By manipulating the sliders, we can adapt the coordinate system to fit into the red square. We press Apply and can now verify our setup. As a beginner, it is recommended to repeat this step several times to gain the best user experience. To repeat this step and to get back to the default settings, we use the Revert to Saved button. The Clear button can be used to clear the position drawing. We press Next to navigate to minimum Z level. In the previous sub-step, we adjusted the XY position. In the following sub-steps, we will adjust the minimum and maximum Z level. The Z level is illustrated in the 3D plot by a green area. Let's adjust first the minimum Z level. We touch the cover within the sensing area again with the same hand posture. At the same time, we manipulate the slider of Z pos min. Increasing or decreasing this parameter leads to an increase or a decrease of the Z level. We adjust the slider until the Z level hits the 0 level. Finally, we verify that the Z level settings works for all XY positions by touching on various positions within the sensitive area. Let's continue by pressing Next. The same procedure applies to the maximum Z level. Again, the green area illustrated in the 3D plot shows the Z level. We set Z pos max to its maximum value. We use again the same hand posture as for the previous steps. Touch the surface and slowly remove the hand in Z direction. The Z position stops at some point. All we have to do is to adjust Z pos max in a way that the top of the grid is aligned with the green Z level. By repeatedly touching the surface and moving the hand in Z direction, we can verify the settings. We press Apply and then Next to continue to the last position tracking sub-step, called Filter Adjustment. The filter adjustment allows the configuration of two parameters, Jitter Reduction and Speed. The Jitter Reduction parameter helps to remove the jitter in the position tracking. Jitter is most likely to appear when the user's hand is far away from the sensitive area and the electrodes, but it can also appear when there is noise on the electrode receive channels. To demonstrate jitter reduction, we set both parameters to the lowest value. If we now hold the hand still above the electrodes without moving, we can see that the position tracking cursor is still moving. Increasing the jitter reduction parameter leads to a decrease of jitter in the position tracking signal. Please keep in mind that high jitter reduction values will lead to a less responsive behaviour and will also slow down the tracking speed. This means when moving the hand from left to right very fast, the cursor will not follow the movement. This leads us to the speed parameter. Increasing this parameter leads to more reactive system and speeds up the position tracking. Once done, we press Next to continue. In this lesson, we learned how easy it is to parameterize the position tracking. Now we can continue with the next lesson, HMM Gestures Recognition.